Welcome to aminacademy.com. In mathematical formulae and their explanation, let us discuss about formulas of derivatives of trigonometric, logarithmic and exponential functions. Here first we'll discuss about derivative of trigonometric functions. Here this side is a trigonometric function, this side is and their derivatives. Sin x derivative is y is cos x, that is dy by dx is cos x. Y equal to cos x derivative is minus sin x, tan x derivative is secant squared x, cot x derivative is minus cosecant squared x, secant x derivative is secant x tan x, cosecant x derivative is minus cosecant x cot x. It is better to remember basic trigonometric functions. Then from that extension, derivative of inverse trigonometric functions. Differentiation of sin inverse x is 1 over 1 minus square root of 1 minus x square. Here x should not be equal to plus or minus 1. If x equal to plus or minus 1, it won't be derivated. That means 1 minus 1 is 0, 1 over 0 is infinity. Then derivative of cos inverse x is minus 1 over 1 minus x square. Here plus 1 minus 1 over x square, here minus 1 over x square. Tan inverse x is 1 over 1 plus x squared. Cot inverse x is minus 1 over 1 plus x squared. Secant inverse x is 1 over absolute x into square root of x squared minus 1, where x should not be equal to plus or minus 1 comma 0. Derivative of cosecant inverse x is minus 1 over absolute value of x square root of x squared minus 1, where x should not be equal to plus or minus 1 or zeros. Next, derivative of exponential and logarithmic function. Derivative of e power x itself e power x. Derivative of a power x equal a power x log x. For example, differential of 3 power x equal 3 power x into log 3. Here e power x is actually d by dx of e power x is e power x into log e, but log e equal to 1, therefore it is e power x into e power x only, because log e equal to 1. d by dx of ln x, natural logarithmic x equal to 1 over x, x should be greater than 0. d by dx of ln absolute x is 1 over x, where x should not be equal to 0. d by dx of log x base a is 1 over x into ln a. Here also x should be greater than 0. Derivative of hyperbolic functions. This side is hyperbolic function, this side is derivatives. Y equal to sin hx, derivative is cos hx. Y equal to cos hx, derivative y is sin hx. Then derivative of tan hx equal y is secant h squared x. Derivative of cosecant hx is minus cosecant hx cot hx. Secant hx is minus cosecant hx into tan hx cot x. Cot x derivative is minus cosecant h squared x. Here sin hx derivative is where minus comes. Next one, derivative of hyperbolic inverse functions. Here inverse function y equal to sine h inverse x, its derivative is y dash is 1 over square root of x squared plus 1. Cos h inverse x is y dash is 1 over square root of x squared minus 1. Weird plus or minus terms. Derivative of tan h inverse x is y 1 over minus 1 over 1 minus x square. Cosecant h inverse x derivative is 1 over modulus x, that is absolute x, square root of x square plus 1. Here these are the limitations, restrictions. And derivative of secant h inverse x is 1 over x square root of 1 minus x square, here minus. Then derivative of cot h inverse x is 1 over 1 minus x square. The restriction is modulus x should be greater than 1. So far we discussed about derivatives of logarithmic, exponential, logarithmic and trigonometric and hyperbolic function and their inverse. We have done. Please subscribe our YouTube channel.